Hello everyone, this is Team Roomba with our arm exoskeleton. Our goal is to design a device that can help individuals who have suffered an injury to a limb, have reduced strength and mobility, and require additional assistance in tasks. Need a helping hand? We got you covered. Many people are suffered of limitation of body functions resulting from some form of injuries. They will need a helping hand, or in our case, a helping arm. In our specific situation, the user that will be referenced is a 53-year-old man who broke his arm in a work-related accident, or in short version, Fabian's father, who is a painter. Fabian's father experienced limited strength in his left arm and has lost the ability to lift loads that are considered common in his area of work, construction and painting. We will focus on returning the ability or attempt to return as much of the ability to lift these heavy loads on a regular basis through the use of extra arm. This is our design arm exoskeleton. We start at an idea of robot arm or exoskeleton. Step by step, we develop it from 2 sticks to our final prototype. Now, let me take you to a journey of our designing process. There are 3 steps for our design. First, evaluation the problem. Second, find the solution. Third, test the solution. Our first problem is comfort. Adding additional weight on the arm can cause some discomfort at the shoulder and result in fatigue. Our solution is use shoulder brace and adding a layer of foam or sponge on the interior of our design. The next problem is materials. Different materials provide different pros and cons. What materials would be the best suit for our robot arm? The material we use for our prototype is ABS plastic, because there is limited time and budget. The piece of the arm was 3D printed and combined to construct the arm. For the raw material we want to use on our design, there is 2 choices: aluminum and carbon fiber. Aluminum is cheap and easy to produce. As for carbon fabric, it is lightweight and has greater durability.
When selecting material, we look at the weight and the strength the material can handle. The material
The device must be able to put on easily by a single person. Making the device easy to put on with one arm will decrease the need of an assistant. We use a clamshell design in our device. The device opens in half like a clamshell, allowing the device to close around the arm. We also use some strips to secure the arm in place. We test how long it will take to wear our device. It only takes use 40 seconds.
We tried paying attention to how easy it was to put on the device, since the user is going to have only one hand.
In order to make our design work, we put a servo motor on the actual arm with a wire attached to the forearm brace. The servo will be powered by a battery and controlled by the user. The servo will supply the lifting force needed to help support the arm, and shoulder brace will be attached to help distribute the load on the individual. With the support of the servo, the individual will be able to continue work despite the loss of strength in the arm.
Ideally, our robotic arm will be lifting up to 60 pounds at roughly 135 degrees.
The idea and physical prototypes of actual arm already exist, so what makes our design different from what's out there? Our device is made for one task and one task only. It is meant to assist in the lifting of objects through a particular range of motion.
This device isn't meant to lift everything. It has one specific task in mind. It's meant to.
For the teamwork, our team is composed by mechanical engineer students and electric and computer engineer students. We contribute a lot in the design and building process of our final prototype. Everyone input their idea and opinion at every stage of the project, and everyone experiments with every prospect of the device, whether it was the electrical circuits or the creation of 3D printing. Everyone was involved in every step. This is what we learned from this project. The process of brainstorming. At first, we come up with a large amount of ideas, and we have to narrow it down to a final decision as time goes on. Time management. We need to know when to make a model for our prototype and how to make the model. And also, we learned that we have focused on our main idea and the purpose of our project. We learn how to be specific with getting our point across the user. Presentation is the key. We need to be able to help our audience understand our design and what its purpose.